I'm Brian Cram. I'm the Quality Engineering Manager at Tiger Logic, which means that I'm the QA programmer, which means they get new features, they feed them to me, and I write something to break them so that I break them and you don't. Let's look at some of the files that we're using here. The transaction files, it's standard transaction file, customer ship to address and things of that nature. This one differs from most files I've seen in that it's one file that encompasses all types of transactions. A lead comes in, it gets logged. If they need a demonstration, that lead becomes a demonstration record, which becomes a quote record if they decide that they want to if they're interested in buying something. They place the order, it becomes an order. When they ship the product, it becomes an invoice. So the presence or absence of these dates, quote date, order date, determines whether or not, or at what point they are along the process. So we have at this point, we're going to look at the code that generates that inquiry that we saw. At which point, this is a proc that calls programs, that calls subroutines. The main sales analysis proc is about 20, 25 procs that call a program and pass it some arguments, whether they want to look at it geographically by state, whether they want to look at it by product, and what type of amount they want to look at. They want to look at their profit, they want to look at their sale, or something of that nature. The proc calls this program below, which collects criteria via that pop-up that you saw, takes those criteria and goes through and gathers all of the transactions that meet that criteria, be it invoices within this region, within this period. Turns around, takes those invoices, numbers that it gleaned, creates a simple matrix, a simply multi-valued table out of them, and then takes the rest of its time here to present the table, like so. So there's a couple of routines in here. I probably should say this. This is not a demonstration of the dashboard. It's simply a demonstration of how to take a simple green screen app and make a simple dashboard out of it. So we're not going to be going into a lot of what's new in the product or anything, but just how to get a dashboard from your application in a relatively quick manner. This is the transaction gathering routine. You can see that goes through, tries to figure out which type of transactions that you're trying to gather, returns the pointers to them, and then the table routine simply takes those pointers, you pass them the pointer and the IDs, and some of the other criteria that were passed to the routine, and creates the table. So we're done with this guy. So let's build a dashboard out of this. So today we're going to build a simple column chart and a simple pie chart against those. This is our column chart. You see that's basically representing the same set of data that you can see here, but in a columnar fashion with one column representing each month of total activity within the region. We've selected the pie chart to represent the same data, but geographically over states. So you can see that the column chart represents the columns, and the pie chart represents the rows against our application. So let's take a really quick look at the dashboard code so you can see what it takes to make one of these. The templates that come installed, we're going to look first at the column chart template. This is a simple 3D column chart, single series column chart. And this is the template that gets shipped when you select to create one of these widgets. I've taken the liberty of narrowing down that template, taking all the comments out there. You can see just how little code is really in these widget subroutines. In the case of a column chart, you've got to set basically 5 variables. You've got to tell the title, which is what gives you the title within the gray bar on top of the widget. You have to tell it what type of widget it is, and you have to tell it how wide it wants to be. When we talk in terms of width, it's either a 1-width, 2-width, or 3-width widget. The dashboard, there are options to how wide the panels that you can set, and you need to tell the widget which of these panels it's going to fit into. That'll become more evident later. And then this is the stuff, this is the code that I laid within the column chart to actually get it to read our data. So what I did, well, the first thing I did was retitle it. You can see up in line 6. I also added some charting options. I wanted to be able to put an x-axis memo and a y-axis memo. So you can see this, this column chart. I've added this 6-month sales by month caption, which is right here on line 16. The sales in US dollars and the to define this axis and also to define the axis along the bottom. This is one of many little options that you have to make these nicer. So what else did I do? The first thing we needed to do, we extracted the period from the system date so we know what our ending period. We're looking at, what does this mean? We're looking at a November through April window for our 6-month period. I then go to get the transactions that I need to make this graph work. So down around here where it says gather invoices for the 6-month period, we're just taking the, we're passing the through period and the fact that we want invoices to the same transaction gathering routine that our green screen app uses to return our list. If we come up with nothing, then we have to error handle. And this is one thing that you really kind of need to get used to within dashboard programming. The most important thing that you must remember about widgets is that they must return. They can't hang, they can't do any screen I/O. They've got to return. If they don't return, you're dead in the water. The dashboard will hang. So where you would normally say open file name to file, else abort 201 with a file name, we've adopted this technique here. You would say do something else, retype the widget in HTML, give it a simple H1 tag that tells you what's going on, and do a return. You could just do a return, but if you do it this way, at least you'll have some help as to where you might have erred or what resource isn't available. Come now, mouse pad. The next thing we do is take those invoices that we gathered using the gathering routine. We've hard-coded some parameters so that we can replicate the first inquiry we were looking at on the green screen app. We're going to look at gross sales by state with the document type of invoice. We go in and gather the table using the same routine that gathers it for the green screen app. And now it's time for us to actually build the table in the dashboard. Well, the first thing I did, the guy who did that table routine embedded the row headings in the table itself. So the first thing I'm going to do is extract or get rid of them. So that's the where I'm deleting attribute 1 out of the table on line 44, if you can see that. Figuring out how many periods there are, and then doing a for next loop and populating the two variables here, the W string bar values, where I will give you a rounded integer, and then the labels themselves, I'm using, creating a more eye-friendly version of the period where I actually use the month name and the year instead of just a bunch of numbers. So let's just remind us. So that our periods look like November-2010 instead of 201011 or something of that nature, a little more eye-friendly. So that's it. That's really all it takes to do a simple column chart. There's not a lot of programming there. Now, the pie chart itself is about as simple. Let's look at the code behind this guy. This is the pie chart template that comes installed with the dashboard product. And again, I took the liberty of stripping out all of the comments so you can see how small the code is. And again, 3 variables that are common to all widgets, which is the title, the type, and the width, and then the pie chart specific. It's just 2 simple multivariate arrays that you have to populate. And here's the code that I used. Same thing I did in the last widget. Set the title to 6-month sales by state, except that one said by month. Generated the ending period, set up a pie caption, gathered the invoices, established the period, went and built the table, and I pulled the row headings out of instead of just deleting the first element, I pulled them out of the first element into my heading routine, or my heading variable rather, and deleted them. I called a little program called remat sub, which it's a little routine that takes an XY table and turns it into a YX table. The only reason I did that is because it's easier, on line 49, it's easier to sum values than it is to go through and add them one at a time. I could have done either way, but that just was easier. That's all it takes to make a pie chart. Now, granted, these aren't very robust charts. All they are, that's the current period, and it's just one grouping. It's by state. So we can actually do better. So let's go and make some additions to this. So we'll go to version 2. Now, what is unique in version 2? Let's see what the column chart looks like now. Not substantially different, except that we can now select our ending period. Same thing with a pie. We can now go through, select our ending period. Let's look at the code that it took to do that. We'll look at the column first. So all I did this time around was, instead of extracting or creating the ending date and calling it through date, I now need 2 date variables. One is the end of the 6-month period that we're displaying in the chart, and the other is the current date, so that we can enable that little drop-down select box for the date period. So let's see how we did that. What we added here, we've introduced an important concept. There are a couple of arrays that are carried in common for us by the dashboard processor. One is widget user data. The other is global temp data, and we're going to be using those heavily here. They are used, widget user data is used so that the widget can pass data to itself, mimicking a persistent session for the user. So that when we select a period, of course the dashboard's already dead and gone. It writes, when you press submit in the browser, it passes it off to the dashboard, which populates this file, so when the widget subroutine runs again, it reads the data that was provided through the browser. So we're going to set up one element of it. We're going to use the first element for our period. Line 26, we're going to populate that with the current period if it has not yet been populated. Otherwise, we'll use what's there. And then the rest of this code from 27 to about 48 is to set up that little drop-down box. There are 6 variables here. The WString input prompt defines the label. The type is obviously a select type. We have a pair of multi-valued arrays, cell ops and cell vals. One is the ops is what displays to the user that they can select, and the cell vals is the actual value that's behind it. So in the case of this drop-down, it says December 2010, but underneath I wanted to say 201012, which is how we process periods within the app. And then the input UD, the UD POS, which is the user data position variable, tells me take the results of the user and put it in element 1 of widget user data sub 1. And then the W input default indicates what our default date is within the dropdown. If you notice, like right here, I've got December 2010. Well, the default is not working. Yeah, I'm going to have to work on that one. What it's supposed to do is remember which selection that I had just recently selected. And I'll fix that as soon as we're done. So, and then we establish a through period. In line 48, we establish our through period for our 6-month spread, extracting that from the widget user data array. And those were the only changes that we made to add dates to the column chart. We made the exact same changes to the pie chart as well, with the exception of the, nope, we did everything in the pie chart we did in the column chart as well. So now we have these two charts operating independently. And the first thing the user said was, hey, that's great, but can't I get them on one page because I don't want to have to keep flipping back and forth. So, okay, yeah, that's a good idea. Let's do it. So, on to version 3, which we now still have our column chart like we always did. And we had the pie chart, like we always did, but we also have the column and the pie chart on the same dashboard. It's great. First thing the user said was, well, no, that's not good because look how big those are. And it's slower because both of the charts have to do the same amount of work to get the transactions. You got to keep scrolling up and down, and you got to set the dates independently. Like here's March 2011. I want to do it once and get it in both charts. Well, okay, that's fair. There's one other thing that we did here. These widget code was getting big. It's getting a lot bigger from all of the stuff that we were trying to do. So what we did in this example is we took a lot of that, a lot of the business code out of there, and we stuck it in an include. So you can see that we, all of this stuff you recognize from the widgets, but you can see now the widget is small again. All it does is do this include and then digest the table that is fed to it. So let's look at the include a little bit. Every piece of code that was in one or the other of the widgets is now in here. Did no modifications whatsoever. So the back to the user's input that this should really be on one dashboard. We agree. Let's take this up to version 4. And okay. That's starting to look a little more friendly because we have everything in one place. If we change our ending period, let's go to January 2011 and submit it. You notice that both of the charts are now operating off the same set of data. And let's go look at the code it took to do that. Let's refresh this. Okay, didn't add a lot in here, but we did add a couple of elements to the widget user data array. We've got like 100 elements in there. We're going to start, we're using 11 and 12 to pass the range of periods that we're using for the particular application, and we're also using a place to stick the table. And now we've also added a test here. This line 8 says if global temp data, sub 1 basically, is not null, then set widget user data to that value. So we've got this variable called global temp data, which differs from the widget user data. Global temp is temporary just for the iteration of the dashboard. TLDB main initializes all these variables. The very first widget can throw something in global temp data, which can be read by the next widget in order. So we've got the pie chart coming up first, followed by the column chart. The pie chart can do some stuff, throw it into global temp data, and the other widget can use it, and that's what we set up. We set up a very important thing here in number 10. We've got a couple of variables that are carried in common. GString widget name tells you the name of the widget that you are. In the instance of the pie chart, I forgot what I called it, but it was pie versus column. What this statement will do is GWidget name list is a list of all the widgets on the dashboard. So this simple if statement says, am I the first guy running? It says, if I am the first guy running, then I am going to go do all of the stuff that we were doing before, which is establishing the month, setting up the input prompts, gathering the data, building the table, and then at the end of it, I throw the table into a common variable, and I throw the periods into a common variable, okay? And then here's the end else statement down around 66. If I'm not the first widget, simply pull all of the stuff I need out of those two variables, widget user data or global temp data, and then set global temp data to equal widget user data so that the next guy down the line can use the code. This allows, this is what allows one widget to do all the work, and I guess for a NASCAR example, the lead car gets all the wind resistance and the widgets behind him can draft him. What else do we do here? So we changed the column chart. The only modification we made of the column chart this time, since it's still using table, it doesn't, the include took care of where he got it, but all we did was change the height of the chart. We introduced a couple of chart optioning items in here. Chart height, 225, we did that so that the column chart could be just as tall as the pie chart, so they weren't staggered. And the chart options. What you may have noticed before, if I hover over these bars, you can see the period and you can also see the dollar value that represents the column. And in this case, it's a full 6-digit comma delimited number, where in the previous example, you know what, let me go back to the previous example. In the previous example, you saw these labels up here, which say like 263K. When you hover over it, it's a 263K. The options have allowed us, first of all, I remove the labels because as you get more bars, these labels can sometimes bleed over each other, which is kind of ugly. But when you hover, you can actually see the real amount that you're looking at. So this is better, and we're almost done because we've almost replicated all of the functionality of the green screen app. But one thing we didn't do, all we replicated was the first choice, and there's a 20. We've got a 6-month gross sales by state pair of widgets. Okay, let's go look at net sales by product. Which is a different set of things altogether. So we need to add some more input prompts and some other items. Let's get to that point. So now you can see that pie widget is a lot taller. So we sized the column chart to be roughly as, well, on my laptop it was exactly the same. This one's a little different. We also added the concept of the table widget to do a pie chart legend, so that we, you know, in case one doesn't know that AZ stands for Arizona, this is a little more relevant when we go to look at net sale by product. See, that product number is not very descriptive, but the legend is. Legend is using the same set of, it's got the same include, and it's getting everything it needs from the same table that's generated. So let's see what we did in this version. Okay, to support the prompts, we added a few more element definitions to our widget user data array. We've added transaction type, the basis amount that we're going to use, be it profit, be it sales, or discount, and we added a group by field as well. We've added the code down around line 14 to carry these widget user data elements from widget to widget using the global temp data array. And we've added a little piece on line 18 of we're not only testing to see if we're the first widget, but we also need to see if we're operating in drill down mode. Because one element that we added is we can now hover over one of these bars, click on it, and get a drill down report based on the contents of the bar. Well, this is a simple HTML widget. It's set up by us. There's only a couple of things you need to do. Let me just go into the code editor on this one and show you what's up. This is the code editor that ships with the dashboard. I wasn't going to spend a lot of time demonstrating it, but you can see that you can just it's a lot easier to use than a telnet window. And this is a simple table widget. The same three variables you have to set: the type, the title, and how much width it wants to consume. It's using the same include, and then it's extracting stuff from the table. There are so all you have to do here is just say, give me a multi-valued set of row headings. Give me or column headings rather. And a multi-valued variable that does column justification. Let's get over here and show that. So if you can see that, notice how the amounts are right justified and the headings are left justified. You control that within there as well. And then all you have to do, we open the files based on what our group by is. We can either open the state, territory, or products file. And then we go through and populate the rows with the row headings that we read from the file, and then for the amount of periods, everything to the right. You can do this, there's an HTML type widget as well to do this, but this is, if you need something quick and dirty and not a lot of features, this is a very handy way to do this. You can make changes to this. I could say, just quick. Compile it. Refresh it. Let me drill down. And, oh great. The field that I changed happens to be redefined further on down in the program, but you guys get the idea here. So let's take a look at the code we've introduced in this version. So that's what the drill down mode is all about. So we began also, we're going to add a bunch of input prompts here, 3 specifically. Setting up at line 29, we're setting up a counter, an attribute counter for the widget input stuff. Added the test for drill down, because if it's drill down, we don't want the input prompts presented. And here's our familiar period select box setup. We've just bracketed it with an if then to say if we're drill down, don't do it. Then we've added all of the code to support the transaction type drop down, which is similar from the other. The basis amount drop down, whether we're using gross sale, discount, cost, net sale, profit, whatever. And the how we're going to group it, whether we're going to group by sales rep, by territory, by product. Setting up all of these prompts here is really the lion's share of what we did. And then in terms of transaction gathering, we've replaced a lot of our hard-coded values. We used to have hard-coded that we were doing by state and gross sale, but now we're reacting to the options that we have used or have gleaned from the user using the select boxes. So we're setting up, rather than we commented out line 121, so we're not setting it to I for invoices, we're setting it to whatever the value of widget user data sub transaction type is. I think that's number 2. That's why you use equates, right? And setting up what we need to pass to the familiar transaction gathering routine. We are no longer hard coding the group by and which document type or which total type we're using. We're pulling those from the widget user data array, calling the same old table generating routine, passing the period in the table that we got from there off to the next widget. And then we've added where we used to send just the period, what period we're using on to the next widget, we're now sending the other 3 arguments as well. That's all in the include. Within the widgets themselves, modifications weren't very big. To support using not hard-coded but the widget user data array, we changed how we set up the Y memo and the caption up here. Here's the line on line 22 of stretching the chart to be a little higher. And then the drill down code underneath. So when we're building the table, we're setting the bar values on line 31 just like we were, the bar labels on line 34 just like we were, and then for each column we're adding a value to the FWDD widget, providing it the widget name and passing off our 4 elements of widget user data to the widget in drill down mode. And that's all we had to do. Here's the same, we made basically the same modifications to the pie chart. This is the complete code for the legend, that legend chart. And that's basically all it took to get us to this point. There's a lot more you can do with this, but I'm running up on time, am I not? Yeah. So let me do something really quickly here. I'm going to throw up the widgets that are on our, you can go to our website, www.tigerlogic.com, go to products, and go to dashboard, and in that there's a tab that says example. And within that example, you'll get everything that I'm showing you here, which is, this is an HTML widget with familiar tables and everything of that nature. This is that table widget, which is showing summary data. Now this is being pulled from some summary files. This is not using the green screen routines, but something had been implemented to summarize stuff on a regular basis in case your application routines are not fast enough to come back to a dashboard rather quickly. Here's an HTML widget. This is just a little bit slicker. You know, you can test values and paint them red or green based on good or bad. Single series column charts like we've seen before. The multi-series column charts where you can have groupings, like this particular one is everything in November that's broken out by territory, or below it, everything that's within the territory that's broken down individually by month. You can hover over and see what the various values are. Bullet charts, these are kind of cool. You can show sales versus goal for each of your territories, and you can create bullets which will show you the red line is the goal and the blue is the sale, so you can tell whether they're making, you know, it's a very simple graphic to see whether they've hit their goal or not. Narrowing it down. We also have pie charts can do the same thing. We've got analysis here. You've got a multi-series bar or a column chart that shows sale versus discount, or cost versus discount versus profit within each of the territories, and you can see the pie slices here for each of the sales reps to see basically how much of the store is each guy giving away. Kill ratios, we have a little tool, a funnel chart, which is really good for this. We can say based on for everyone within the territory, we've had a number of inquiries, and 42% of those become demonstrations. 12% of them become quotes, and we're giving a 3.7% orders to inquiry kill ratio, which is, you know, good or bad depending on your industry. Same set of kill ratios represented in a multi-series column chart here. And then we got this really neat demographic tool. We can look at the western region, and we can look at our activity. Red represents heavy activity. The tan is kind of moderate activity. We can set that to be inquiries, and we can actually look at our order demographics. And you can see that some light activity in Arizona and Nevada, which I understand completely. The heaviest activity in Colorado, which doesn't surprise me at all. We can look at it for just one guy. Let's look at Ben. And he operates just within Utah and Arizona, and the other areas have no activity whatsoever. You can hit a state, drill down, and you can look at the demographic information for a county. Let's look at everybody here so I can tell what's happening within each county, and from within each county you could do a drill down to come up with a report that shows customers, you know, a customer ranking report or anything that you can imagine. So, you know, there's a lot of cool stuff here. There's a lot of really easy to program. And that brings me to the conclusion.